Welcome back to the Datarekha audio guide. I'm Diya.
And I'm Arjun. Today, the 6 versus B decisions that show up in every system design interview. And the trick is that none of them are really about the products. They're about contracts.
Contracts. Unpack that because database versus cache sure sounds like a product comparison.
It sounds like one, but the interviewer isn't checking if you memorize two definitions. They're checking whether you can name the one operational property that forces the choice. Durability. How long a job runs. Whether you can replay, consistency, recall, or tracing a single request. Name the property and the answer falls out.
Alright, start at the top. Stateless versus stateful. And please, not the textbook line.
Here's the real test. A stateless instance doesn't need its own memory of past requests to handle the next one, so any healthy replica can take the call. A user logs in, sessions exist. Does that make your web server stateful? No. If the session lives in a shared store and every replica can check it, the server is still stateless. But flip it. A stateless worker that leans on an in-memory cursor nobody else has? That's stateful in the only way that matters.
So the question isn't, is there any state? It's, does this box own state that nobody can rebuild if it dies?
That's the whole thing in one sentence. State that lives somewhere durable and shared doesn't count against the compute. State that one box owns, and that has to be restored or replayed or reassigned when it dies. That's what makes you stateful.
Next pair. Lambda versus a long-running container, ECS. How do I pick here?
Lambda runs a function when an event fires, and every invocation must assume its local memory and disk could vanish. There's a hard 15-minute ceiling per run. It shines for bursty, sporadic, event-driven work with short handlers. EC schedules containers that just keep running. Better for steady APIs, custom runtimes, a process that has to sit there listening, or a job that won't finish in 15 minutes.
Here's a trap I'd want to avoid. A warm Lambda remembers things between calls and a container holds memory too. Can I lean on that?
Never. Both of those are catches, not promises. A warm Lambda or a running container may keep memory around for a while, but neither guarantees that one specific instance survives. The instant your correctness depends on that reuse. You've built a bug that passes every test and then fails in production.
Good. Database versus cache. And I think you'll say the cache never gets to be the source of truth.
Exactly right. The database is the system of record. Transactions, constraints, the recovery log. The cache is a faster, disposable copy under an explicit staleness policy. The hard part is never, how do I call Redis? It's defining the policy. Which write invalidates the key? How stale is tolerable? What happens when 1,000 clients miss the same hotkey at once? And the brutal litmus test. If losing Redis means losing the only copy of an order, then Redis was your database all along, no matter what the diagram labeled it.
Queue versus stream next. They both move messages around. Where's the line?
A queue is work waiting for an owner. Competing workers grab a message, it goes invisible. They acknowledge success, or it retries. And because delivery is usually at least once, your workers have to be idempotent. A stream is an ordered history of events, retained for a window. Different consumer groups can each read the whole sequence independently. And because it's retained, you can replay last week after fixing a bug.
So if I just need one worker to resize one image, that's a queue. If 3 separate systems all need to read every event, and I might replay them. Stream.
You nail the fork. The real products blur it. Redis Streams has consumer groups. Kafka can distribute within a group. So you choose from the contract. Do you need retention and replay and independent readers? Or do you need per-job ownership with acknowledgement and a dead letter queue?
2 more, retrieval versus re-ranking. In a RAG pipeline.
Picture a funnel. Retrieval is the cheap, wide first pass. It scans millions of chunks fast and aims for high recall, just getting the useful documents somewhere into the top 100. Re-ranking is the expensive second pass. A richer model that looks at the query and each candidate together and reorders for precision at the very top, narrowing 100 down to 5.
And here's the thing I'd want a junior to internalize. If my recall at 100 is bad, a fancier re-ranker can't save me, right?
That is the single most important consequence, and it's a hard ceiling. The re-ranker can only reorder what retrieval handed it. If the goal document never made the candidate set, no re-ranker on earth conjures it back. So you measure the two stages separately, because end-to-end answer quality alone can't tell we never retrieved it apart from we retrieved it but ranked it 40th. One is a retrieval bug, the other is a ranking bug, and they have opposite fixes.
Last pair. Monitoring versus tracing.
Monitoring is population health. Metrics aggregated across everything. Error rate, P95 latency, queue age, token cost. It tells you whether the fleet is sick and pages you. Tracing follows one single request through every service as a tree of spans. It tells you where that one request spent its time or died. The gateway, the retriever, the re-ranker. A database retry.
So a real incident is the two working together. The alarm, then the autopsy.
Exactly the flow. A latency alarm pages because P95 crossed the line. That's monitoring spotting the symptom. You grab one slow request's trace, and it shows 2.4 seconds stuck in the re-ranker call after 3 retries. That's tracing localizing the cause. The metric saw the fever. The trace found the infection.
So the one idea tying all 6 together.
Good architecture is almost never A everywhere instead of B. Each pair lives at a different boundary, and a single real system uses both halves of all 6. Don't compare the products. Name the property that forces the choice. That's the Datarekha audio guide. See you in the next one.